Hey Yarmilies, this video is specifically for you. Just checking, there we go. Okay, everything's set to go. So you said, how about number 5? So this is number 5. This is a single displacement reaction. The reason why that's important is that's going to help us determine so what's going on here. So now I have, like if you've seen single displacements before, this is a metal plus a salt, and that's my A, this is my B, and this is my C, which means that on the other side then I'm going to get A with C plus and then B by itself. Okay, so let's go through. I'm going to show you B itself is CR with a plus 3 because of that right there. So that tells us that that's a plus 3. The C is NO3 with a minus 1, and the B of course is BA. But over here, BA has a plus 2. Because BA always has a plus 2 when it's in a compound, and NO3 with a minus 1, so we're going to have to do parentheses, and we can get rid of the charges there, good, and then plus, and then CR, and that's going to be a solid. Now how do you know that's a solid? Well, CR is by itself. It doesn't matter whether you put a solid, a liquid, or a gas for CR. It all ends up being the same because CR is by itself, and it does change from one side to the other. So if I write the complete ionic equation, what I get then is, oh, I didn't balance the equation, so let's balance that. I have 3 NO3s on the left-hand side, but 2 on the right-hand side. So let me see if I can move this thing. Ooh, I can't. I can move part of it, though, like that. Move it over just a little bit, like that. And then what I do is if I put a 3 in front here, that gives me 3 BAs and 6 NO3s. That gives me 3 BAs on this side. There, now we're the same. And how do I get 6 NO3s on this side? Well, I have to put a 2 in front because 2 times 3, gives me 6 total, so that works. And then I need a 2 all the way down here, like that. So now that I have a balanced equation, now I know that I can write the complete net ionic equation, or the complete ionic equation, as 2Cr with a plus 3 plus 6 NO3 minus plus 3 Ba solid, like that. And then on this down here goes 3 Ba with a plus 2 plus 6 NO3 minus plus 2 Cr solid. Now the fact that I have a solid and a plus 3 means that they are not the same, so they stay. The only thing that's different, or I'm sorry, the only thing that's the same on both sides is my 6 NO3 here and my 6 NO3 there. So that means after I get rid of those 2 spectator ion, well, the same ion that's a spectator ion, I write down my Cr, 2Cr plus 3, 3 Ba, oops, that one's the solid, like that. And then on the other side, 3 Ba plus 2 plus 2 Cr, and that one's the solid. And that's it. That's how you do all of it. So anything that doesn't change from one side to the other is what we're crossing off. Do you see how, I just want to make sure, do you see how I got 6 NO3 here? The 2 times the 3 gives me 6 NO3s, and that's why it comes down as a coefficient here. Okay, just want to make sure that's obvious. Thanks, I hope that helps. Let me know.